In this video, we're going to be doing a quadrilateral area math problem. So here's the problem statement. So in the diagram, square PQRS has a side length of 40. Points J, K, L, and M are on the sides of PQRS as shown, so that JQ is equal to KR is equal to LS is equal to MP, which is all equal to 10. And that means that the line segments J, Z, K, W, LX, and MY are drawn parallel to the diagonals of the square so that W is on JZ, X is on KW, Y is on LX, and Z is on MY. So what is the area of the quadrilateral WXYZ? And our possible answers are 280, 200, 320, 240, and 160. And this is our diagram here for this question. So we're going to be looking through this question again. So just before we go into our solution for this problem, first try to solve this by yourself. And if you're unable to get the solution for this, the answer, then we're going to get into our solution right now. So first, let's just summarize what the question is saying before we go down to our solution. So first, what the question is saying is that this is going to be square. So PQRS is a square, this big square here. And next is saying that it also has a side length of 40. So each one of these has a side length of 40. And then it's saying that points J, K, L, and M are on side of the length here for on PQ, PS, QR, and SR. So you can see that they're all on here. And next it's saying that this here, and this here is going to be equal to 10. And then it's also saying that these are all parallel to the diagonal of the square. And then basically we're just trying to find out what the area of this WXYZ is. So now let's get into our solution. So for our solution, this is what we're going to be first finding out. So first we're going to be finding out quadrilateral WXYZ are parallel to the diagonals of the square PQRS. So first let's find out what this is. So it's saying that the quadrilateral QWXYZ is parallel to the diagonals of the square PQRS. So what we need to do is, all we have to do is just draw our diagonals. So let's just draw a diagonal here. So this would be one diagonal and this would be the other diagonal. So we can see here that these are going parallel compared to the diagonals of the square. As you can see is this line, these two are parallel to this line here, and these two are parallel to this line here. And then next what we're trying to see is that the diagonals of the square are perpendicular. So if we just erase this and draw our diagonals once again, so it's saying that the diagonals of a square are perpendicular. So what we can see here is that we have this as a perpendicular because as soon as we get this intersect here, we can see that this would be equal to 90 degrees, which means it's perpendicular. And same thing with this one here, these are all going to be perpendicular. And then this means that WXYZ has 4 right angles and thus is a rectangle. Since we know that this is perpendicular, we know that there's going to be 4 right angles, which is going to be one here, one here, one here, and one here. And since we know that there's 4 right angles, we're just going to assume that it is a rectangle. So this is just going to be our first part of the solution. So we're just trying to figure out what this shape here is. And furthermore into our solution, so to calculate the area, we're just going to be extending this here, KW, all the way until T, and then we're going to be joining T to M. And same thing here, so we're going to connect from Z all the way to M, and then just make this line here. So what we're going to get is just this line here, so it looks like this. That's what we're going to get. And now since the diagram does not change when it's rotated 90 degrees, 180 degrees, or 270 degrees, WXYZ is a square. So what it's saying here is that since even if we rotate this, so let's say we took this here and we made it and we pushed it over here, so then it's going to look like this. So as we can see, as we rotated it 90 degrees, it's still going to be a square. And if we rotate it over here, it's still going to be the same. And if we rotate it here, it's still going to be the same. So with that information, we know that it's going to be a square since it does not change. The shape doesn't change as we rotate it. Since we have this information and we know that this is a square, let's just get into our solution and try finding out what the area is now. So now from the diagram, we already know that PT is equal to 10 and PM is equal to 10. From our question here, we know that PM and PT is equal to 10. Since we're looking for the side length of one of these, all we're going to do is just use the Pythagorean theorem to find out what the side length of this one is. And since we know that this is equal to 10, this is equal to 10, then we can just use it to find out what this is. And once we know what this line here is, this one line here, then we can just easily figure out what the area would be, because we just have to square it. Now all we need to do to find out this length is just going to be square rooting both PM squared plus PT squared. And we know that PM and PT is equal to 10, so we're just going to be square rooting that. And now all we do is we just add these two up, and we know that that's going to be equal to 200. So that means MT is going to be equal to the square root of 200. So we figured out what this length is, and all we need to do now is just square that in order to find the area, since we already have one length. And now the area of WXYZ is going to be equal to MT squared, which means that we're going to get our answer as 200 after doing the math. So that means the answer for this question is B, 200. So thank you so much for watching from Try to Be Useful, and we'll see you guys in our next math problem.